Okay, this video focuses only on example 2 of the 9-6 notes, and it is all about looking at a graph and writing a sine and cosine equation. I'm going to follow this set of steps, and then we'll talk about some of the shortcuts you might be able to see from looking at the graphs. But this is something you'll come back to next year in pre-calculus as well. So if you follow these set of steps, you'll be able to do the even more difficult graphing problems next year when you're given less information than what we've got in the next example. So I'm going to ask you guys to write sine and cosine equations for the curve. We know sine and cosine are the same curve. One is just a phase shift of the other. So we're going to represent the curve with both sine and cosine equations. So that's step 1. You're just going to set up a template, and then we'll fill in the blanks as we go through the rest. Step 2 is then finding the amplitude first. Step 3 is finding that sinusoidal axis shift, so the vertical shift up and down. Step 4 is the hardest one that we'll see, which is finding the frequency in order to plug that into the equation where we would see B. And then the last one, step 5, this is the only thing that's going to differ between sine and cosine, and that's that phase shift. And we will talk about that at the very end of the next couple of examples. So I'm going to refer back to this table with all these steps. But we're going to turn the page and we're going to look at example 2 here. So 2a, we want to write the sine and cosine function for the sinusoid shown. So step 1, and I'm going to label them. Step 1 says write a template. So y is equal to some amplitude times the sine of some frequency times x, and then in the inside will be our phase shift. On the outside is going to be the sinusoidal axis shift. And then we want to do cosine next. And the rest of this problem is just going to be filling in the blanks here. Okay? So step number 2 says find the amplitude first. Now, the amplitude is always max minus min divided by 2. Amplitude is half the height of our whole curve. So if you see these 2 points that we're given a maximum point, we're given a minimum point. The maximum is 5, the minimum is -1. So this becomes 6/2. The amplitude here is 3. Okay, that's the first thing we fill into the blanks. Now, everything is going to be the same for sine and cosine except the phase shift, except what we will find in step 5. So I'm going to fill in a 3 into those blanks at the very front in front of sine and cosine. All right, next step. Step number 3 tells us to find the sinusoidal axis shift, or K, that vertical shift. So we can do this in 2 different ways. We can take the maximum value and subtract the amplitude, or you could take the minimum value and add the amplitude. You should get exactly the same value either way. If you get something different, then something's wrong there. All right, so that tells us that our graph is shifted up 2. So that is going to go at the very end there. And what I'm going to do is I'm going to go into this curve and I'm actually going to sketch the sinusoidal axis. This becomes way more important when we see less information, but I think it's nice to see that sinusoidal axis because we also know that there are key points that lie on the sinusoidal axes of each of these curves as well. Right? And those are harder to see if we don't have that sketched in. All right, step number 4 is the most involved. There are 3 steps to step number 4. So 4a, the first step tells us we want to find the sub-interval length, and then we can find the period, and then using the period, we can find the frequency. Okay, so the sub-interval length, we are given 2 values along the x-axis. So I'm going to look at the min and the max. There's actually a few ways that you guys could do this, but I'm going to do it one of the more complicated ways so you see the math behind that. So from that max to the min, we're looking at the length of that interval. So the length of that interval is 3 pi over 8 minus pi over 8, right? 2 pi over 8 is the length of that interval, or pi over 4. Okay, next, how many sub-intervals are between that max and the min? Well, the sub-intervals are the intervals between key points. So there's 1, there's 2. Remember, there's this key point at the sinusoidal axis. There are 2 sub-intervals between pi over 8 and 3 pi over 8. So we're going to divide that interval by 2 in order to get the subinterval length. So the subinterval length here is pi over 8. Okay, so then the next part is we're going to take that subinterval length, we're going to find the period. There are 4 subintervals in one period. So we take the subinterval length and we multiply by 4. That is going to be pi over 2. That's our period. The last step then is to find the frequency. That is always the standard period of sine or cosine divided by the period of our curve. So our frequency here is going to be 4. That goes in right before x for our sine and cosine curves. Okay, now here's another way we could have looked at that. Instead of looking at pi over 8 and 3 pi over 8, we also have a point at 0. So between 0 and pi over 8, which is up here, this maximum, we have one subinterval. So the subinterval length can be pi over 8. I just wanted to show you how to do it separately. Another way we could have seen that is at pi radians. We're back on the sinusoidal axis. So how many curves do we see between 0 and pi? Well, this is one curve. This is 2 curves. So between 0 and pi radians, we see 2 curves. So our period then is pi over 2. We could have skipped to that point as well. There are many different ways that we could go about finding the information here. The steps that I've given you guys on that core concept box, that will get you to the right answer every single time if you can't see it immediately. Okay, very last thing we're going to talk about then are the phase shifts. So if you look at the cosine curves and the sine curves in step number 5 in that box, what we need is when we're writing a cosine curve, we either need maximums or minimums. Now it's positive cosine if we find a maximum, and it's negative cosine if we write the phase shift with a minimum. So I'm going to do, let's just use the maximum. We're at a maximum at pi over 8. So we've moved to the right pi over 8, which means for cosine, right pi over 8 is represented by minus pi over 8 as a phase shift. Now sine is a little different. When we're looking for a phase shift for sine, we start sine on the sinusoidal axis. So you're going to find a sinusoidal axis value. Now it's positive sine if you look at that sinusoidal axis point and then you're moving up from there. So we have a point at 0. So we actually don't need a shift here. Don't write the plus 0 on your homework. But we're not going anywhere left or right for sine. All right, let's try one more, and then I'm going to have you guys try C on your own. These are the trickiest ones. This is actually one of the hardest pieces about graphing sine and cosine, is writing the equations. And they get trickier next year when I give you harder graphs that don't have as much information. Okay, so I'm going to set up this template for sine and cosine first. That is step number 1. Okay, step number 2 then, find the amplitude. So we take the max, we subtract the min, and we divide by 2. So our amplitude here is 2, and that is going to go right in front of sine and cosine. All right, step number 3 then, we're finding that shift, the vertical shift k. So that is either take the max and subtract a, so that is -1. So we have a shift. This time we're moving down 1. -1, -1. Okay, I'm going to sketch that sinusoidal axis in just so we can see those other key points where we touch the sinusoidal axis. And then we're going to go into step 4, which is that most involved step. So part A is telling us to find the subinterval length. So let's do it this way. Instead of using the points that were given, I know I've got a point here at 0. All right, that's the point 0, -1. And between 0 and 1/2, there is one subinterval. So our subinterval length is 1/2. Okay, part B then says find the period. We take the subinterval and we multiply it by 4. So the period in this case is 2. And then the last step then is to take the frequency by using 2 pi, the standard period, dividing it by the period of our function. So the frequency here is pi. So frequency goes right after sine and cosine in our equation. And then the last thing is the thing that differs. Those are the phase shifts for sine and cosine. All right, so again, let's talk about what we're looking for. Now, for sine always starts on the sinusoidal axis, so pick a sinusoidal axis point. I'm going to pick that 0, -1. That means that we have a phase shift of 0. We don't move left or right for sine. So you could say +0, -0. You're actually not going to write 0 in your homework. But we want to make sure that we have the correct sign. So starting on that axis, moving upward, that is positive sine. If I had picked this axis point here, we would have had to make sure we use negative sign because we were starting at the axis and moving down. Okay, how about cosine? Now cosine, we always need a cosine value at either a max or a min for the phase shift. So I'm going to skip that maximum. I'm going to use this just to show you another way. That is a minimum value. That is to the right 3/2. So right 3/2 is -3/2 on the inside with x. But because we're starting at a minimum there, I need to make sure that this is the reflection of cosine. I need to have that negative in front of the equation. So there are more than just one answer you could represent for any of these curves. There's an infinite number of points that we can use for those phase shift values. So pick the one that works best for you. Give C a try. The answer is online. And then watch the next video for the applications.